Let us solve some numericals on potentiometer. Question number 1. A potentiometer wire has a length of 1.5 meter and a resistance of 10 ohm. It is connected in series with a cell of EMF 4 volts and the internal resistance of 5 ohm. Calculate the potential drop per centimeter of the wire. So that's the diagram. The yellow line is a wire of length 1.5 meter, capital R as 10 ohm, and E is equal to 4 volt. The internal resistance is equal to 5 ohms. We are supposed to find V upon L. So we use the formula using Ohm's law, I is equal to V upon R, and also I is equal to E upon R plus small r. So we can take the two equations and make a formula V is equal to ER upon R plus small r. So let's substitute. So V is equal to 4 into 10 upon 10 plus 5, which is 40 upon 15. So V is equal to 8 upon 3, which is 0.267 volt. But we are supposed to find V upon L. So V upon L is 8 upon 3, and L, as we know, it is 1.5. Substituting, we get V upon L is 1.777 volt per meter. But look at the question. It is asked as calculate the potential drop per centimeter of the wire. So converting meters to centimeters, we get V upon L as 0.0178 volt per centimeter. Let's take the next question. When two cells of EMFs, E1 and E2, are connected in series so as to assist each other, I hope you can imagine. The cells are resisting each other. Their balancing length on a potentiometer is found to be 0.3 meter. Compare the EMFs of the two cells. So we have got L1, the balancing length, as 2.7 meters when the cells assist each other. And when they oppose each other, we have L2 is equal to 0.3 meters. We will find E1 upon E2. So sum means the negative of E1 is connected to the positive of E2. And difference is when the negative of E1 is connected to the negative of E2. So we have the formula E1 upon E2 as L1 plus L2 upon L1 minus L2. So let's substitute, pretty easy. E1 upon E2 is equal to 2.7 plus 0.3 upon 2.7 minus 0.3, which is equal to 3 upon 2.4, which gives you 10 upon 8, which is nothing but 1.25. Let's take the next question. The EMF of a cell is balanced by a length of 120 centimeter of potentiometer wire. When the cell is shunted by a resistance of 10 ohm, the balancing length is reduced by 20 centimeter. Find the internal resistance of the cell. So we have got the cell as balanced on L1, that is 120 centimeter, and we have L2 as 100 centimeter. R is equal to 10 ohm. So we are supposed to find small r. Now how did we get L2 as 100? It is 120 minus 20 because the balancing length is reduced by 20. So L2 is 100. So that's the diagram of our internal resistance of the cell we are supposed to find out. We have capital R as 10 ohm in the diagram, as you can see. We have the formula, the very easy formula, small r is equal to capital R into L1 minus L2 upon L2. The direct formula, just substituting small r is equal to 10 into 120 minus 100 upon 100. That gives you small r is equal to 2 ohm. Let's take the next question. A potential drop per unit length along a wire is 5 into 10 raised to minus 3 volts per meter. If the EMF of a cell balances against the length 216 centimeter of this potentiometer wire, find the EMF of the cell. L1 is 216, K is V by L, 5 into 10 raised to minus 3 volt per meter. What is your E1? So that's the diagram. E is equal to KL1, E is equal to V by L into L1. So we substitute E is equal to 5 into 10 raised to minus 3 into 216 into 10 raised to minus 2. So E is equal to 0.01081 volt. The next one. The resistance of a potentiometer wire is 8 ohm and its length is 8 meter. A resistance box and a 2-volt battery are connected in series with it. What should be the resistance in the box if it is desired to have a potential drop of 1 microvolt per millimeter? So you have capital L as 8 meters, Rp parallel 8 ohm. Potential drop E is equal to 2 volt. Potential drop is 1 microvolt per millimeter. So that gives you 1 into 10 raised to minus 6 volt per meter upon 10 raised to minus 3. That is 10 raised to minus 3 volt per meter. So V is 10 raised to minus 3 volts. So what is R? Capital R. So E upon Rp plus capital R is V upon Rp. So you get 2 upon 8 plus R is 10 raised to minus 3 upon 8. So capital R is 15992 ohm. So next time we will do the problems, numericals of voltmeter. Also, a voltmeter has a resistance of 30 ohms. What will be its reading when it is connected across a cell of EMF 2 volt having internal resistance of 10 ohms? So R is equal to 30 ohms, and we have this resistance 10 ohm connected in parallel with the cell E is equal to 2 volt. So R is 30 ohms, E is 2 volt, R small r is equal to 10 ohm. So I is equal to E upon capital R plus small r. I is equal to 2 upon 30 plus 10. That gives I is equal to 1 upon 20. So V is equal to IR by Ohm's law. So V is equal to 30 into 1 upon 20. That gives you capital V as 1.5 volt. A voltmeter again has a resistance of 100 ohms. What will be its reading when it is connected across a cell of 2 volts having internal resistance of 20 ohms? Again, the same circuit diagram. R is equal to 100 ohms, E is 2 volts, small r is 20 ohms. Again, I is equal to E upon R plus R, so I is 2 upon 100 plus 20. I is equal to 2 upon 120, so I is 1 upon 60. V is equal to IR again using Ohm's law. V is 100 into 1 upon 60. That gives V is equal to 1.66 volts. This is same as the earlier one. So that's all. Thank you.